the topic is resolving power of microscope. So here I have the object, so it pass in this way, and it makes an angle beta. So this is the convex lens, and this convex lens is gives the image in this way. So this is the image plane, and this is the object plane. This is the image plane, and this is the object plane, and this is the distance between the object and the convex mirror. I named it as F, and then here I have the distance between the convex and the image plane. I named it as a V. Okay, so commonly I have the distance A. Okay, so here only the way is being separated. So I have made this as a by 2 and a by 2. Okay, so this is the resolving power of the microscope diagram. So now we'll get into the derivation. So now theta is equal to 1.22 lambda divided by a. So already we have seen one topic regarding the resolution. So then the resolving power is it equally opposite to the resolution topic. So that is opposite. Okay, it's equally opposite in nature. Okay, so now the theta value, already we found this value. So theta is equal to r naught by f. So now I can change this equation as r naught by f is equal to this theta value. Okay, in the place of theta I am writing 1.22 lambda divided by a, and remaining I have r naught by f. Now take this f to that side, so it will become r naught is equal to 1.22 lambda f divided by a, it will come. So now I am going to replace this f with the symbol V. So Y means to apply the magnification formula in the below case, so only I will get the final answer. So for that reason I am replacing the f with V. So this equation will be turned into 1.22 lambda V divided by A. So that is equal to R naught value. For the magnification we have one formula, M is equal to R naught divided by the distance minimum. So when I will get the large image, means the minimum distance between the points will result in large image. So for that reason only the distance will be in the minimum, so that I will get the large image. So a magnification is equal to R naught divided by D minimum. Okay, so now I am going to rearrange this equation. I need the D minimum distance, which means the minimum distance. So that is equal to R naught divided by M. So already I have the value for R naught. So just substitute that value. D minimum is equal to 1.22 lambda V divided by, and already I have the A in the R naught value itself, and this M is there. So here I am going to apply the magnification value as V by U, which is nothing but image and object. So now D minimum is equal to 1.22 lambda by V. I have written as it is. Then A in the denomination. So the M value is V by U. So V by U. So this V and this V will be get cancelled. So when this U goes to here, it will become inverse 1. Then again it goes up, means it will be U. So I can write D minimum is equal to 1.22 lambda U divided by A. So here is U is approximately, I can write this is an F. So I can write U as F. So then I will get D minimum is equal to 1.22 lambda. In the place of U, I have replaced the letter F, then divided by A will come. So now the angle is very small. Okay, so I am going to take the sine theta. So here I have the angle beta. So here opposite divided by adjacent. So opposite is nothing but A, and the distance is 2f. Okay, because the 2 distance I am taking. So sine beta is equal to a by 2f. So now I can write this equation, 2 sine theta is equal to a by f. Okay, so now take this equation and arrange it. Okay, so I take 1 by 2 sine beta and f by a. Okay, so like this cross multiplication. So then the resolving power, now only this equation only, it's very very important. So D minimum is equal to 1.22 lambda f divided by a is the formula that we already discovered. So in this formula we are going to substitute the value f by a value. So here in the numerator I have f, and in the denominator I have a. So just substitute the value. So D minimum is equal to 1.22 lambda. The f by a value is what? 1 by 2 sine beta. So write that in the denominator. So now the objective microscope in oil of refractive index. Okay, if I have placed the objective microscope, that object in the oil index, nothing but the refractive index, in some medium, so that is called oil immersed objective. So I can now introduce the letter n here because of the refractive index. So d minimum is equal to 1.22 lambda divided by 2n sin beta. Okay, so here I can take n sin beta is equal to the numerical aperture. So numerical aperture is nothing but aperture is lens. Okay, the lens what we are using here. So n sin beta is equal to numerical aperture, and I am going to represent it with Na. So now this equation will be turned into distance minimum is equal to 1.22 lambda divided by 2 Na. So now the resolving power of microscope. So Rm is equal to, take this like this, 1 by T minimum, and here this to the numerator and this to the denominator. So 2 Na divided by 1.22 lambda. I have written Na because of the n sin beta value is Na because of the numerical aperture. So now this is the resolving power of the microscope. So hope you can able to understand it very clearly. Take the screenshot and copy this in your notebook with the neat diagram.